the notes for lesson 5.5 part 2, completing the square in vertex form and intercept root form. If you remember 5.5 part 1 in the first part of chapter 5, we looked at how to complete the square. So now we're going to look at how we can go from one form to the next form, or from one form to vertex form, using completing the square. So just a reminder, vertex form is y equals a times the quantity x minus h squared plus k, where the vertex is hk, the axis of symmetry is x equals h, and a is the vertical stretch of the graph. So from standard form, in order to get to vertex form, we have to complete the square. So we know that our formula for completing the square is here. So example 1, we're writing the quadratic function in vertex form. We're giving the coordinates of the vertex and the equation, the axis of symmetry. So once it's in vertex form, we have to give those two other things. So our equation is y equals x squared plus 10x minus 3. If you remember, we need to fill in, or we need to create our spaces or our squares or our boxes that we need to fill in our function. So what we need to do is add 3 to both sides first. That will create for us our box that we are trying to find. So we have y plus 3. We're going to add our box equals x squared plus 10x, again plus our box. So as we talked about before, to complete the square, we needed to take 10x, divide that by 2. So this is going to be x plus 5 quantity squared. And we're going to square the 5 to get what goes in the box. So 5 times 5 is 25. So we're going to add 25 to both sides. So on the left hand side, we get y plus 25 plus 3, which is 28. Now you can leave it like this for vertex form, or we can also subtract 28 to both sides to get y equals x plus 5 quantity squared minus 28. Both of these equations are considered to be in vertex form, so whichever way you write it, either way is correct. Now to find the vertex, remember we look at our equation. So our vertex comes from our h and our k. So if we have x plus 5, remember that's the opposite. So our x coordinate is negative 5. And then our k is negative 28. Remember the axis of symmetry comes from the x coordinate of our vertex. So the axis of symmetry is x equals negative 5. So again, we complete the square. That will get us into vertex form so we can easily see our vertex and our axis of symmetry. Example 2, we're doing the same thing. We need to write it in vertex form and then give the vertex and the axis of symmetry. So again, we want to move the negative 45 so we can get that space or that square for our c value. So if we add 45 to both sides, we get y plus 45. And again, we're going to add our box in there, because that's what we're adding to both sides, equals negative x squared plus 14x plus our box. Now notice that we have a negative in front of our x squared term, so we need to factor that out. So we're going to keep on the left hand side everything the same. And on the right hand side, we're going to factor out a negative 1. So we get x squared minus 14x plus our box. So then from here, we're going to divide b divided by 2. So I'm going to keep this the same. So I have negative 1 times x minus 14 divided by 2 is 7. So x minus 7 quantity squared. And then I'm going to square the 7 to get 49. Now I need to go all the way up to the original box. We factored out a negative 1. So we're actually multiplying 49 times the negative 1 to get negative 49 in our original box. So that's what we are adding to the other side as well. So this should be a negative 49. So negative 49 plus 45 gives us a negative 4. So y minus 4 equals negative 1 times x minus 7 quantity squared. So make sure you go all the way up to the very top boxes and fill those in, and that will get you the correct answer on the left hand side. So vertex form, we're going to add 4 to both sides. So we get y equals negative x minus 7 squared plus 4. Or again, we could write it as y minus 4 equals negative times x minus 7 quantity squared. Either way is correct for vertex form. So again, if we look at our function, our vertex, our h value is 7, our k is 4, so our vertex is 7, 4. Axis of symmetry again is the x value, so the axis of symmetry is x equals 7. So again, to get from standard form to vertex form, we have to complete the square. That will get us into vertex form so we can easily see where the vertex is located in our function. And our last form is intercept or root form, and that's y equals a times the quantity x minus p times x minus q, where the x-intercepts or the roots are p and q, and the axis of symmetry is halfway between those points. So to get from standard form to intercept form, we need to factor. So for example 3, we're writing the quadratic function in intercept or root form and identifying the roots of the function. Notice our a coefficient is negative. Whenever that's the case, we know that we want to factor out a negative like we talked about in section 5.2. So y equals negative 2x squared minus 3x minus 20. Now if we look at what's inside the parentheses, since we have a trinomial, we can set up our t. So we have 2x and x on the left hand side. On the right hand side, we're looking for factors of negative 20 that are going to add up to be negative 3x. So I'm going to try 5 and 4. Now since we have a negative 20, either 5 or 4 needs to be negative, but I need a negative 3. So I'm going to make the 4 negative, because that will give me a negative 8 and a positive 5, which will give me the negative 3 that I need. So my factors are y equals a negative, and then 2x plus 5, and x minus 4. Again, our factors come from the top and the bottom. I know some of you had a hard time coming up with the factors when we did our quiz. Again, it comes from the top and the bottom of our t. So the intercept root form is y equals negative 2x plus 5 and x minus 4. Again, it doesn't matter which order we put the factors in, as long as we have both correct. So then to find the roots, we just need to set each part equal to 0. So 2x plus 5 equals 0, and x minus 4 equals 0. So x equals a positive 4. And if we solve for x here, we get 2x equals negative 5. So x equals negative 5 halves. So our roots are negative 5 halves, 0, and 4, 0. So again, to get from standard form to intercept form, we just have to factor, and then we can easily find those roots on our graph. The last part, I just want you to practice identifying each equation in the form that it's in. So I want you to go through A through F. I want you to go ahead and shut off the video when I'm done talking here, and I want you to tell me which form each of these equations is in, based on what we have talked about. Tomorrow in class, we will go over which form each of these is in and how to determine the forms and how to identify them for each of your equations.